Eisen wakes up late on average 3 days out of every 5. If Eisen wakes up late, the probability that he is late for school is 85%. If Eisen doesn't wake up late, the probability that he's late for school is 25%. We're going to create the tree diagram by filling in the probabilities. And then we are going to use that to answer this question down here and find the percent chance that Eisen gets to school on time. So, according to this first sentence, it says Isaac wakes up late 3 days out of 5. So, 3 out of 5, that would be 0.6. So, that is the number of days or the probability that he's late. So, that would be your probability for A. So, 3 out of 5, when you put that in decimal form, that's 0.6. And if he's late 60%, or if I should say if he wakes up late 60% of the time, then he wakes up on time 40% of the time. So B is going to be 0.40. Now, it gives us more clues to fill out the rest, the lower branches. It says if he wakes up late, the probability that he's late for school is 85%. So if I follow that track, he's late, which means he's late for school. If I follow this track that I just highlighted in purple, that would give me this value for C. Value for C is the probability that he's late for school given that he woke up late. So that's our 0.85. Now, if he wakes up late, and 85% of the time he's late for school when that happens, that means the complement of that would be 15%. So our D would have to be 0.15. So if we're looking at just this branch, A, then C and D is going to be broken up into 0.85 and 0.15. Now, another clue that's given to us in the problem, it says if Ian doesn't wake up late, then the probability that he's still late for school is 25%. So if I follow that track down this branch, if he wakes up on time, but he's still late, that's this branch E, that would be 25%. So this is going to be 0.25. So 0.25 is the probability that Ian is late even though he has woken up on time. So the probability that he's late given that he woke up on time, that's this probability here, E. Which means if he wakes up on time and given that he was on time when he woke up, if 25% of the time he was still late for school, that means 0.75 or 75% of the time he was on time for school. So now we have all the values for our tree. So let's use this to answer our question. It says we want to find the probability that Ian gets to school on time. Now there are two ways that he can get to school on time. If you follow the tree, he could wake up late but still be on time. That's this portion here. And then using a different color here, you can see the other route he would be on time. He could wake up for school on time and be on time. So we're going to use and follow these branches to find those probabilities. So if we want to find the probability that he's on time, there are two ways to do it. That he follows the branches A and D, that A and D happen, or that B and F happen. We know in probability that and means multiplication and or means to add. So I'm going to find the probabilities for A and D, multiply them together. So A is 0.6 times D is 0.15. So that's the probability that he wakes up late and is on time, or means to add. And now I need to find the probability that he's woke up on time and he went to school on time. So that's branch B, which we said was 0.40, times branch F, that probability, which was 0.75. Now, when we put all that in on the calculator, we find this value, we find this value, and then we add them together, you should get 0.39. So the probability that he gets to school on time, is 0.39 or 39%.